Hey, Period 5 students, we're going to take a look at your quiz from last Thursday, walk through a couple of those answers so you can see how you did well or you didn't do well, and then you can have a chance to retake that if you come to office hours. Let's get started. So if you look at this, we have the fraction x to the fifth over x to the third. Again, that's x to the fifth, so you want to expand that. You get x to the 1, 2, 3, 4, 5, right? And x to the third, 1, 2, 3. So that's the expanded form. So taking a look at this one here, we have n squared times n to the sixth times n to the third. Remember the product rule. We can just add exponents, or you can write this out and count them. Just make sure that you're not as sloppy as I am. And you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or you could say n to the second times n to the sixth times n to the third is n to the 2 plus 6 plus 3, which gives you n to the 11th. All right. Remember, the best way to do this is to go grab your own Desmos, review, look it over, take some notes, and use this to study and to learn, right? This is what this is about, learning. So if we look at this guy, y to the third, all to the fifth power. Remember, when we take a power to a power, it's the same as multiplying those powers. I get y to the 15th. You could write out y to the third 5 times, and then use your product property. All right, here we have a quotient, right? b to the fourth over c to the fourth, or b to the fourth, c to the fourth over b to the sixth, c. So we use the subtraction rule here for quotients, right? So we have b to the 4 minus 6 and c to the 4 minus 1. Sorry, that's a 4. 4 minus 6 is negative 2, and c 4 minus 1 is 3. You could write it like this. That's not incorrect. It has the negative exponent. Or you could write it as c to the third over b to the second. Either one of those is appropriate. Let's try the next one. And so here we go. We have 14 m to the third over 2m to the third. Maybe you recognize right away that you could just simplify m to the third divided by m to the third is 1. Then you'd be left with 14 over 2. 14 divided by 2 is 7. Much easier than you thought, right? If you didn't see that, you could still say, well, I know 14 over 2 is 7. M to the third over m to the third can be m to the 3 minus 3, or m to the 0. Anything to the 0 power is 1, so you have 7 times 1, which is 7. All right, so this is how I really know you understand this. Can you create 3 expressions that all combine or simplify down to k to the 12th? Some of you use the easiest ones, right? We can use the product rule, and we can actually say just about any combination of numbers that will add to 12. So k to the second times k to the 10th. Remember, we add those exponents. 2 plus 10 will give us k to the 12th. We could say k to the 5th times k to the 7th. Those add to 12. K to the 11th times k to the 1st. Those add to 12. The possibilities are near endless. Well, they are endless if you want to get really crazy and use negatives. All right, another example would be using the quotient rule. If we need to get to 12, what if I did 13 over k to the first? 13 minus 1 is 12. But we could have any combination that gets us to 12. 24 over 12. We could have 15 over k to the third. Again, if it's a quotient, they subtract to 12. That will give you the correct answer. And then finally, we could use the power rule, right? K to the second times, let me restart that. K to the second to the 6th power. We could have k to the 2 times 6, which is k to the 12th. Do you know anything else that multiplies times together to get to 12? You could have k to the third to the 4th, or k to the 4th to the 3rd. You could have k to the 12th to the first power, all of those will multiply to get to 12. And so they all work as examples. All right, I hope this was helpful. Again, come to my office hours if you want to talk more about it. But until then, you can do it.